Okay, let's talk about trigonometry. So I just made a whole full recap page for you guys. I will post this on the group. It's basically everything you need to know about trigonometry, including negative angles, reduction formula, the double angles that we were taught this year, compound angles that we were taught this year. I'm going to remind you people, you only get a formula sheet at the end of the year. At the end of the year, you will have this on the formula sheet, but for now, you need to know what these identities are. Got the grade 11 identities over here. I've even went as far as making sine squared theta the subject of the formula, so that you know. All I did was I took this over and making cos squared theta the subject of the formula by taking sine squared theta over. I remember in class someone asked me about what's this, the reciprocals and stuff like that, so I listed them down for you. Okay, I drew a diagram for you so that this here is a nice reference of where exactly we're getting things, because when some of the teachers started, they started with sine being opposite over hypotenuse, and a lot of the physics students also learn it as SOHCAHTOA. So all I did was I related it to you people's knowledge of the Cartesian plane. I put it in the first quadrant. Okay, and if this is our reference angle, this is opposite, and can you see the side here corresponds with the y-axis? That's why we have y over r, because our hypotenuse corresponds with the radius, meaning if I put a pin, the protractor and pencil over here, make a full circle, if that's easy enough to visualize. Speaking of quadrants, I've got the reduction formulas over here. Okay, I separated it into the one where co-functions have to happen, so your sine becomes cos, cos becomes sine, and the ones where there isn't co-functions that change. So in this quadrant 360 plus, or else it's the acute angle. Remember, with reduction formula, we are trying to get it to an acute angle. Okay, there we go. I've also listed the negative angles for you guys. Sine sine of a negative angle, negative sine that angle. Cos of a negative angle, positive cos of that angle. Tan of a negative angle gives us negative tan of that angle. Alright. I also listed here for you things that you need to know how to do. So simplify using reduction formula, negative angles, compound angles, double angles, however they give you the question, whichever one of those things are available for you to use. Then you get questions where it says, if sine theta is equal to P or Q or whatever it is, write this in terms of P, or write this in terms of stuff like that. Then you need to know how to simplify, prove identities, so your left hand side equal to right hand side, and you need to know how to work with your general solution. And that's exactly what this video is going to show you, all of those stuff. Let's get into it. Okay, so I started with simplification. Okay, sorry, this looks very scary. Let's start right at the top. Okay, this is the question, this part over here, question. I'm going to pause. Please copy down the question. Make sure you're working with me through this video, okay? So you understand exactly what you're doing. All right. So I have 2 sine squared 166. Remember, I just mentioned that we want to get all of them to acute angles, and we want to try and simplify where they can cancel each other out. So what I'm going to see is, if it's 166, 166 is in which quadrant? It's in quadrant 2. How do I know it's in quadrant 2? Let me show you guys my reduction formula. See, it's in this quadrant over here. It's less than 180 degrees, but more than 90 degrees. So that's how I know it's in quadrant 2. If it's in quadrant 2, I'm using this reduction over here. All right. That's exactly what I did. See how I wrote everything else exactly as it is? I'm just changing the 166. Oops. 166 like this. And how did I get this 14? Okay, mental maths, or else if you in the test and you're all stressed out, you just say 180 minus 166, get your answer, right? Same thing for the 10. I figured out which quadrant it is. In that quadrant, what's the reduction formula? I put it there. I have cos 824. Now what did I do? You're going to look at this and you're like, whoa, how did I get from 824 to 180 minus 76? This is what I did. 824 minus 360. Now you agree with me, if I do a full 360, I'm going to end up back at the same place, All right, and then if I do another 360, I'm going to end up back at the same place. So now I'm asking me myself in which quadrant is 104, and that's in quadrant 2, therefore 180 minus. Okay, and this is what I did. I said 180 minus. That's how I got the 76. And then sine 14, left it as it is. Now with our reduction formula, please don't forget you need to consider what the sign of each of these ratios are going to be in those quadrants. Like for example, in the second quadrant, only sine is positive. In the third quadrant, only tan is positive. In the fourth quadrant, only cos is positive. And in the first quadrant, all of them are positive. So you have to consider that. And you can see over here, I made a silly mistake by putting a negative, right? It isn't a negative because in the third quadrant, tan is positive. So this had to be a positive. All right, I simplified this by just taking this part of it, okay? By only taking this part of it. By taking this part of it, you see there's a negative because cos in the second quadrant is negative. All right, you do not have to show as many steps as I did. This is purely for explanation purposes. You can jump steps, okay, as long as it makes sense and we don't know that you use the calculator. Okay, what did I do over here? I changed my tan into sine over cos because of my identity, and I simplified this sine, and this sine becomes sine squared of 14. It cancelled out with that one over there. What else? Initially I cancelled out my negative and negative until I realized, oops, I made a mistake, so that doesn't cancel out. But what we are left with over here, sorry, where am I? I'm left with a 2, I'm left with a sine 14, and I'm left with the cos 14. And then I realized, oh, okay, it didn't need to cancel with anything, so it's back still at the 2 tan 14 degrees. Sometimes when you open things out, you're like, oops, I didn't need to open them up. No one's going to penalize you for opening it up like this and putting it back into the identity of tan 14. No one's going to penalize you with that. Okay, once I got to this part, I just double checked that I didn't make any mistakes. How do you do that? Because it's working with numbers, you can substitute this entire thing onto the calculator. Okay, then say minus and then open a bracket and put in your whole answer. And if the two of them work out and give you exactly 0, you know that you did everything correctly and no mistakes. But if it gives you some weird decimal or whatever, you know you made a mistake, then you need to go back and try and figure out where your mistake is. As you can see, I did it the first time and I got a decimal and I was like, whoa, I made a mistake somewhere. Then I went back and I found my mistake. And there it was. It was the negative. Okay, next question. I have cos of a negative angle times sine of 90 plus. This looks interesting. 270 plus. Oh, this shouldn't be a theta. My bad. This is 270 degrees plus sine theta plus sine of 90 degrees. Okay, interesting. I see two brackets next to each other. Guys, please feel free to use difference of two squares if you need to, or FOIL if it's like two brackets multiplied by each other, highest common factor if you see a common factor. You can even simplify it using your, factorize it using your trinomial knowledge, right? You are allowed to use any of those things. Anyway, let's continue. Cos of a negative angle, we discussed this, it gives us cos theta. This here is 90 degrees plus theta. Let's go back to this page I made. Okay, 90 degrees plus theta. 90 degrees plus theta. This is in the second quadrant, right? So that means sine is positive in the second quadrant. And we also know that sine becomes cos, cos becomes sine. So we look at this, the original part of it, sine, it's positive in that quadrant. Okay, so therefore my answer still remains as positive. It's 90 plus. It's going to change. Okay, that determined the plus. And it's going to change to a cos theta because sine becomes cos, cos becomes sine. Like I'm repeating myself. Okay, this here is a special angle, right? We expect you to know sine of 270 degrees is -1. But if you didn't know that, oops, even if we say without the use of a calculator, you are just going to type it in and you're going to work it out. All right, or else you think about your sine graph and you know that in your sine graph where -1 is, you're going to see 270 degrees. So that's another way of knowing it. Okay, this one stays the same, and sine of 90 degrees is 1. This looks oddly familiar, and maybe it only looks familiar to me because I'm teaching grade 10s about factorization. But if you see here, if I rearrange this around, end up like this. This looks like the brackets from difference of two squares, which is exactly what I did. I squared them. Right, difference of two squares. Then I noticed that this here also looks oddly familiar, just not in the way that I want it. I'll show you guys. Let's put it like this. This is what I have, sine squared minus 1. Here I have 1 minus sine squared to give me cos squared. So what I did was I took out a negative as a common factor, leaving me with this, making this part here cos squared, like I just showed you from the identity. Cancel, cancel, and there's our answer. Then what I also did was I just typed this whole thing back onto my calculator. In the place of theta, I used 5. You can use 5, 10, 15, doesn't matter what number you use, as long as you keep in the same theta for all of them when you're plugging it in onto your calculator. And you see that it works out to -1. Okay, one more example with simplification. I think this is one. Yes, one more example. Okay, one more example. So this one here, what do we have? Okay, acute angle, acute angle, acute angle, acute angle, acute angle, acute angle. So I know I'm not really using any of my reduction formula, but I can see that I have cos 6525, sine 6525. And we learned this here, compound angle. So this here is the compound angle in its expanded form. So I'm going to bring it back to its more closed or simplified form, right? If it's cos, sine, we know that that's going to be a cos 1. And if it's a plus over there, it needs to change to minus, first angle minus second angle. That's what I did over here, right? 65 minus 25 gives me cos of 40 degrees. Okay, let's go back to all the other stuff we have. 2 sine 40, brought it down. Cos 10, brought it down. Didn't touch them. Okay, now I notice something over here. I have 2 sine 40, cos 40. That looks oddly familiar. Let's go back to our double angles. Why do I keep putting it skew? 2 sine of a particular angle cos of the same angle gives us the double of that angle when it's with sine. So I'm changing this here to sine 2 times the particular angle, which happens to be 40. 2 times 40 gives me the 80. And I see here at the bottom, cos of 10, right? Cos of 10 can be changed to 90 degrees minus 80 degrees, isn't it? To give us 10 degrees. And when we're doing 90 minus or 90 plus or 270 minus or 270 plus, go, right? Sine becomes cos, cos becomes sine, which is exactly what I did over there. That cancels with that, leaving me with 1. So now you guys all know how to simplify. These are the type of questions that you will get. All right. Let us move on to the questions that are in terms of, I'll show you guys how to draw the diagrams.